Hi friends, in this lecture we will study Fourier series of continuous time periodic signal. As we have already studied that signal based on continuity, signal can be divided into two types. Signal can be continuous, signal can be discontinuous. There is one more criteria, signal can be periodic and signal can be non-periodic. So we have already studied signal can be continuous and signal can be discontinuous. Again, in continuous signal it can be periodic, it can be non-periodic or aperiodic. In the same way, in discontinuous signal also it can be periodic and non-periodic. There are four categories: continuous periodic, continuous non-periodic, similarly for discontinuous signals. So here first we will study Fourier series representation of continuous periodic signal. Okay. Similarly, later we will study Fourier series representation, and in case of non-periodic signal we will study Fourier transform. Similarly, for discontinuous periodic signal we will study DFT, discrete Fourier transform, and for non-periodic DTFT, discrete time Fourier transform. So let us start with continuous time periodic signal, Fourier series representation of continuous time periodic signal. So in Fourier series representation of a signal, any signal which is periodic, it can be represented as a series of sinusoidal signal. When I say sinusoidal signal, it can be a sine function as well as it can be a cos function. Cos function is also a type of sine function with 90° of phase difference. So what it says in Fourier series representation, any function which is periodic, it can be represented as a series of sinusoidal functions. Let's say we have a signal ft, continuous time periodic signal. Let's say ft is, let's say this is periodic signal and this is its time period, and the frequency will be 1/t and angular frequency will be 2π/t. Amplitude is A and this is minus A. This is a continuous time periodic signal with time period t. So according to Fourier series representation, this signal ft can be represented as a series of a summation of sinusoidal signal. Okay, if it is represented as different sinusoidal signal, so sinusoidal signal will have some frequency. So we will start with the minimum frequency will be equal to frequency of the original function. Okay, what we have to do, we have to represent this original signal in the form of sine and cos. There will be some cos function and sine functions. So if you have a sine function or cos function, obviously it will have some frequency. This is also a periodic signal, so it will certainly have a frequency. So in the representation of ft, there will be many sine function and cos function. Okay, so let us first talk about frequency of those sine and cos function. So the first sine and cos function, the frequency of this signal will be equal to the frequency of original signal ft. So what is the frequency? F or omega naught. So the first cos signal or first sine signal, this will have frequency omega naught, and this is a function of time. Obviously it will have some amplitude. Let's say this is unknown for now, but whatever is the amplitude of cos term, we will represent it with A. and whatever is the amplitude of sine function, we will represent it with b. Okay, so in both the terms, the frequency of the sinusoidal term signal is omega naught, and it is equal to the frequency of original signal ft, that has to be represented in the form of sine and cos. So omega naught is called, this is called fundamental frequency, fundamental frequency or fundamental angular frequency. Now we will have to add more terms. Okay, this both term collectively called the fundamental component of ft. Okay, but to complete ft, in the complete representation, it will have more sine and cos term. Let's say, so it will have, here we have to represent more cos and sine terms, so it will also have some frequency. So the next frequency or all the frequency will be now integral multiple of omega naught. Okay, we started with omega naught, and in all other terms the frequency of cos and sine term will be an integral multiple of omega naught. So here we will have a cos term with double of, here we have omega naught, then next in the next term we will have frequency of 2 omega naught. Here we have double, so I will represent amplitude of this component with a2, and similarly we may have sine term, sine 2 omega naught. Here we will have b2. Okay, this both term, in both of this term the frequency is double of the original frequency of signal, so this will be called second harmonic of f2, f function ft. Similarly we may have third harmonic plus a3 cos 3 omega naught t plus b3 sin 3 omega naught t, and this way it may go up to infinity. The nth term will be an cos n omega naught t plus bn sin n omega naught t, and this way it will go to infinity. Okay, so this is about, this is Fourier series representation in which a signal which is not necessarily a sinusoidal signal, this can be written in the form of, or in the combination of, or in the summation of sinusoidal signal. And we will start with sinusoidal signal having frequency equal to the frequency of original signal ft, and rest all the sinusoidal terms will have frequency that will be integral multiple of fundamental frequency. Okay, so if I say ft can be represented in this form, it means that they will have some amplitude, and if you will add all these signals you will again get ft. What I am saying, representing ft in this form, this means if you will add all these signals you will again get ft. Let me give you some idea how it can be, how a signal which is not sinusoidal, and if you will, for this signal there are some sinusoidal signals, and if you will add all those sinusoidal signals of different frequency and different amplitude, you will get a square wave. Why? What is the benefit of doing this? We have a square wave, and there are some advantages of representing an arbitrary periodic signal in the form of sinusoidal signal that we will see later. I will show you somewhere in the coming lectures. While representing it, we talked about the frequency of different sinusoidal signal. I have not talked about the amplitude, that we may find later. We will find later. We will have some given function ft, and if ft is known, we can find out this amplitude. One more thing in this representation, if you will find out average of ft is a general periodic signal. It is not necessary that average of ft will be 0. If you have this kind of ft, this is also a periodic signal, but its average of ft is not equal to 0. Okay, so you may have some average value and this is equal to this signal. If you will take average of all this signal, what you will get? Average of all this signal will be individually average of all the sine and cos terms. And what is average value of a sine and or cos term? Average of sine, if you have a sinusoidal signal, if in one time period, if you will calculate average, you will get same positive and negative area. So average of sine or cos, this is always equal to 0. Okay, so if you will take average of this signal, you will always get 0, while the average of ft may not be equal to 0. So in this representation we will add one more term which is not sinusoidal signal, and this will be average of ft. So this is complete Fourier series representation in the form of sine and cos. Okay, so we have a square wave, and I want to give you some idea how by adding different sinusoidal signal we can get a square wave. Let's say in the first term, here you will have some sinusoidal signal. Let's say this is the fundamental component of this ft. So if you are drawing the fundamental component, frequency of sinusoidal signal will be equal to frequency of original signal. It means the time period of original signal and time period of sinusoidal signal will be same. So in one time period of original signal, this sinusoidal signal will also complete its one time period or one cycle. Okay. So what I said earlier, if you are representing ft in the summation, in the form of summation of sinusoidal signal, by adding all those signal you must get ft. Obviously you have one sinusoidal signal and this is obviously not equal to this, the square wave. So you will have to add more terms, more sinusoidal component, such that by adding all those sinusoidal component you have to get a square wave. Okay, so how can you make it a square wave? In the square wave you have constant amplitude, so you have to lower this peak and you have to increase this part. So I will add. Now if you will add these two signals, what you will get? You have to lower this peak and you have to increase it. So if you add these two signals, can you realize what we want? You are adding a positive to this value, so this will go up, and if you see here in this graph you have a negative value, so this will come down. So if you will add these two, I hope you will get this type of signal, but it is not, it came closer to, if you compare with this shape, it came closer to a square wave, but it is not, still not equal to a square wave. So you will have to add, you may have to add more terms. Okay, what is this harmonic? This is fundamental component and the duration in which this graph completes one half cycle. In the same duration, this sinusoidal signal completes 3 half cycle. It means rate of change here, the frequency is here 3 times. So if it is fundamental component, this will be called third harmonic. Okay. I did not make second harmonic because I already know in the representation of Fourier series representation of this square wave, you will not get second harmonic. Okay. So similarly, you may need more sinusoidal signal. Okay, you may need fifth harmonic. So what you realize in this expression, although I have written all the harmonics here, in the general formula you will have all the harmonics, but you may not necessarily need all the harmonics. Suppose in the formation of a square wave, we started with fundamental component. There will always be a fundamental component. Okay. So after fundamental component, I did not make second harmonic. So in the formation of that square wave, or in the formation of ft, if we don't need second harmonic, what will be the value of a2 and b2? a2 and b2 will be 0. It means we don't need second harmonic. So in this representation, I want to convey that it is not necessary in the formation of ft all the harmonics will be present. Okay, you may here I tried to show how by adding different sinusoidal signal you can get a square wave. If you are reading with Oppenheim, this is the book for signal system. So in this book, more harmonics are drawn, and they added all those harmonics, and they showed that by adding more harmonics you will get a wave which shape will be more closer to, which shape will be closer to a square wave. Okay, so I hope you got what is Fourier series representation, or you would have got idea about Fourier series representation. And we talked about the frequency of the sinusoidal terms. I did not talk about the amplitude of different component. Like in the formation of a square wave, I made a fundamental component and I made amplitude of third harmonic very less. So what will be the exactly amplitude? So if you know the f function ft, you can find out the amplitude of different component. So now we will derive formula to find out the amplitude of different harmonics. Suppose for ft, for some ft which will be given, if you are required to find out Fourier representation of a signal ft, obviously ft will be given. Without ft, for which function you will find out the Fourier series representation. So ft is completely given, its time period, its frequency, its amplitude, everything will be given. And for this ft, suppose we are required to find out a0, a1, b1 and the amplitude of all the sine and cos terms. So first, starting with a0, as I already said that a0 is average value of ft. Okay, or how we will find it? If you integrate both sides, if we integrate ft from 0 to t, if we integrate both sides, what you will get here? a0 dt ft plus a1 cos omega naught t dt plus integration of b1 sin omega naught t dt plus a2 cos 2 omega naught t dt plus b2 sin 2 omega naught t dt integration, and this way integration of all the terms. Okay, we are integrating for a duration 0 to t. What I said, we are integrating for a duration 0 to, or for a duration of time period. If I am saying that if we are integrating for a duration of time period, it is not necessary that we have to take lower limit as 0 and upper limit as t. It can be anything, but the duration must be t. Like it may be from minus t by 2 to plus t by 2. Okay, so instead of writing lower and upper limit, I will just write integrating over a duration of t. If I write t here, it means The duration of integration for this function is one time period. Okay. So what will be integration of this term? A naught is constant, a naught, and let's say it is from 0 to t dt. What you will get here? A naught t 0 to t. So you will get a naught into t. We'll get here a naught into capital T. What is integration of this term over a time period t? First, what will be the frequency of this term or the time period? This is fundamental component, so the frequency of this signal will be equal to frequency of ft, or the time period of this signal will be equal to the time period of ft, and t is nothing but its time period. So the time period of this cos signal is t. Now if you will integrate a sinusoidal signal for a time period, what you will get? Let's say you have a cos signal and you are integrating it for one time period starting from 0. Here you have one complete time period. So integrating from 0 to t means you have to add all this area. So you can observe that the positive area is equal to the total positive area is equal to total negative area. So you will get the integration will be 0. It is not necessary that you have to integrate from 0 to t only. Again I am making cos function, and let's say this is t by 2 and this is t by 4. If you will integrate from t by 4 to starting from t by 4, okay, and if you will add t to this t by 4, you will get 5t by 4. So if you will you are integrating from t by 4 to here you have t and here 5t by 4. So if you are integrating for this duration, again you will get 0 area. Here you are getting negative area for one half cycle, for other half cycle you are getting positive area. Okay, so for a sinusoidal signal, if you are integrating it for complete duration or you are integrating it for one time period, you will always get the integration as 0. And you can also verify it mathematically. Integration of cos omega naught t from 0 to t. This will give you 1 upon omega naught sine omega naught t 0 to t. This will be sine omega naught into capital T minus sine omega naught into 0. Okay, so omega naught into capital T will be, omega naught is 2 pi by capital T into t. This will give you sine 2 pi minus this is 0, and sine 2 pi is also 0, so you will get 0. Okay, but I will prefer this method. So integration of, here you have cos term, even for sine term same rule is applied. These both integrations are 0. Now coming to this term, what is the frequency of this signal? The frequency of this signal is 2 times of fundamental frequency. It means, let's say this is fundamental component, and let's talk about this since I made sinusoidal signal. The frequency of this signal is double of fundamental component. It means, let's say this is sine omega naught t, and here you have to draw graph of sine 2 omega naught t. So its frequency is double. It means the duration, this is t, the duration in which sine omega naught t completes one cycle, in the same duration sine 2 omega naught t complete 2 cycles. Okay, so in the same duration it will complete 2 cycles. Here one cycle and here 2 cycles. And what we learned from the previous discussion, in any complete cycle the total integration will be 0. So here we have 2 complete cycles. In this cycle we have total integration 0. In the second cycle also we will have total integration 0. Or we can understand it this way: the duration of integration for this signal is, sinusoidal signal is t. And if we talk about time period of this signal, what is time period of this signal? Time period of cos omega naught t, this is fundamental component, so its time period will be t. And you have 2 omega naught t here, so what will be its time period? Its time period will be t by 2. If ft is time period t, if at will have time period t by a. Okay, so for this sinusoidal signal, its time period is t by 2. And what is the duration of integration? Duration of integration is t. Duration is equal to t, and time period here is t by 2. If you divide duration by time period, you will get 2. It means it will complete 2 cycles. So, and in complete 2 cycles, total integration will be 0. So here we can conclude that if the duration of integration for a sinusoidal signal, if the duration is integral multiple of time period, the total integration will be 0. What I am saying, if duration is integral multiple of duration, its duration of integration is integral multiple of time period of sinusoidal signal. This will include sine and cos. Okay, sinusoidal signal, integration will be 0. Integration will be 0. Because if duration is integral multiple, it will have complete cycles. It may have 4 cycle, 5 cycle, depend upon what is this factor. Okay, so similarly for the next term, what we will have, for the next term we will have integration of a3 cos 3 omega naught t. Now in Fourier series, now all the harmonics are integral multiple of the fundamental component, or the frequency of all other harmonics are integral multiple of fundamental component. So if we talk about third harmonic, its time period will be t by 3, and we are integrating for a duration of t. So what does it mean? Duration divided by time period is t by 3. So we again have duration is integral multiple of time period. So it means in a duration of t, this signal will complete 3 complete cycles. In the duration of t, this signal will have 3 complete cycles. It means in any complete cycle, integration is 0. So its integration is also 0. When this integration was not 0, suppose you have a signal a3 cos 1.4 t, and now you are integrating it for a duration of t. So its duration is t, and its time period will be what? T divided by 1.4. Now if you will divide it, you will get 1.4. It means the duration is 1.4 times the time period, and this 1.4 is not integral multiple. So in this case, we will say the duration is not integral multiple of time period. So in this case, the integration may not be 0. So now you would have got idea. Any integration of any higher term will be 0 if you integrate for a duration of t. Let's say we have an cos n omega naught t plus bn sin n omega naught t. What is its time period? Where n has to be an integer, because in the definition of Fourier series representation, what we said, the frequency of all harmonics must be an integral multiple of fundamental component. So what is its frequency? Its frequency is n omega naught, and it has to be an integral multiple of omega naught. So this is omega naught, and here we have integer. Okay, so its frequency is n omega naught. So what will be its time period? Cos omega naught t has time period t. So cos n omega naught t will have time period t by n, where n is an integer. And what is duration of integration? Duration of integration is t, and time period is t by n. So you will get n, means duration is n times the time period. So in the duration of t, this signal will have n complete cycle, and if you have complete cycles, the integration will be 0. Okay, so in the left hand side, when you will integrate both sides, in the left hand side you will have ft dt, and in the right hand side you will have a naught into t, capital T, and rest all the terms are 0. So what is a naught? This will be 1 by t integration over a duration of t ft dt, and this is nothing but, this is the definition of average value of any signal ft. This is nothing but average of ft. So this way we found out the value of a naught. Now we will again multiply both sides with, we will manage to find out the coefficient a1. Okay, here we have to find out a1. How did we find a naught? To find out a naught, we just integrated both sides for a duration of capital T. While doing so, in the right hand side we had only a naught, and integration of all other parts are 0. So the unknowns a1, a2, b1, b2, all the unknowns disappeared. Here what we have to do, we have to manage such that in the right hand side a1 will be here, a1 will be there, and all the constant disappears. So for doing that, let us multiply both sides with cos omega naught t. First we are multiplying both sides by cos omega naught t. So we will get, why to multiply with cos omega naught t? Because if we will multiply with cos omega naught t, here we will have a square term. Okay, and in other term you will get sinusoidal signal, which is other term will not have a square. Now if you will integrate a square term, if you will draw the graph of cos square theta, it will have this kind of graph. Okay, so it does not produce any negative area, so integration will never be 0. So this integration of this term will not be 0, and we will see what is the value of integration of other terms. Okay, so if we will multiply with cos omega naught t, here we will get a1 cos square omega naught t plus here b1 sin omega naught t into cos omega naught t plus a2 cos omega naught t into cos 2 omega naught t plus b2 cos omega naught t into sin omega naught t and rest terms. Now if we integrate both sides for a duration of t, what will be this integration? Okay, let us first calculate this integration. If we calculate a1 cos square omega naught t dt, this will be a1 by 2 into 1 minus sin 2 omega naught t dt. Okay, a1 by 2 integration dt minus integration sin 2 omega naught t dt for a duration of t. This will be a1 by 2. What will be this integration? For dt you will have t, and if you take limit from 0 to t you will get capital T. And what is integration of this term? Again the same concept, you are integrating for a duration of t, this is duration, and what is its time period? This is second harmonic, the frequency is double, so its time period will be half. Time period is t by 2, so this is duration is an integral multiple of time period, that's why its integration is 0. So you will have a1 into capital T divided by 2. Its integration is a1 into capital T by 2. What will be integration of this term? You are its time period is t, you are integrating for complete cycle, so its integration will be 0. What is integration of this term? This is nothing but b1 half sin 2 omega naught t dt. Again its duration is t and time period is t by 2. Duration is integral multiple of time period, so its integration will be 0. Coming to this term, here we have cos A into cos B. Cos A into cos B equal to half cos A minus B plus cos A plus B. So for this term, we will have half A2 cos A minus B will give you omega t minus 2 omega naught t. If you will subtract, you will get minus omega naught t, and cos minus theta is cos theta, so I will write it as cos omega naught t plus cos A plus B will be cos 3 omega naught t. You have to integrate it. So integration, its time period is t, integrating for complete cycle, its time period is t by 3. This will have 3 complete cycles, so its integration will again be 0. Similarly, with the same concept, okay, sin omega naught t cos omega naught t, cos omega naught t sin 2 omega naught t. So in the same way, if you will expand it, this is sin A into cos B. What is sin A into cos B? This is half sin A plus B sin 3 omega naught t plus sin A minus B sin omega naught t. Now if you will integrate with the same principle, with the same rule I have explained, duration is t and time period is t by 3. Integration is 0, here also integration is 0. So in the same way, integration of all other terms will be 0. So what we will get here, in the left hand side we have integration of ft cos omega naught t, and in the right hand side what was the integration of this term? Integration was a1 into t by 2. So what will be the value of a1? A1 will be 2 by t integration for a duration of t ft cos omega naught t dt. Okay, you have to find out coefficient and function will be given. Let's say this is the square wave. Function is given. What is omega naught t? This is also not an unknown. Omega naught is fundamental angular frequency of ft, and ft is given completely, so omega naught will also be given. So this way you can find out a1. Similarly, if you are required to find out b1, so we will multiply both sides with such a quantity such that after integration this term does not go to 0. So to prevent this term from going to 0, we need to multiply both sides sine omega naught t. So in the left hand side what you will get, ft sine omega naught t dt integration for a duration of t. This is important. We have to keep the duration of integration t. This way only we will get integration of this term which will not be equal to 0, and integration of all other terms will be 0. We have to keep the duration of integration t. Okay, in the right hand side corresponding to this term we will get a non-zero value, and that value will be, we'll have integration of b1 sine square omega naught t dt for a duration of t, and integration of all other terms will be 0. In the same way we have done earlier in case of finding out capital A1. Okay, and integration of this term will be b1 into t by 2. So what will be the value of b1? 2 by t integration for a duration of t ft sine omega naught t. Okay. Similarly, if you have to find out a2, what you will do, you will multiply both sides with such a quantity such that integration of this term does not go to 0. So that quantity will be cos 2 omega naught t. Okay. So in that way we can get a2 as 2 by t integration for a duration of t ft, and what you will multiply here, you will multiply both sides with cos 2 omega naught t. So in the multiplication here you will get cos 2 omega naught t dt. Similarly b2, and similarly for nth term, let's say you have the nth term is an cos n omega naught t plus bn sin n omega naught t. So if you have to find out an, you will multiply both sides with cos n omega naught t. So an will be 2 by t integration over duration of t ft cos n omega naught t dt and Bn will be 2 by t ft sine n omega naught t dt. Okay, so this way we understood from starting what what is a Fourier series representation. Okay, then we talked about frequency, and finally we calculate what will be the amplitude of different sine and cos terms. Okay, so we have formula for coefficient, and let's say for this square wave, for this periodic square wave, we have to find out Fourier series, or we have to convert this signal, or we have to represent this signal in the form of sine and cos. So what will be the value of a naught for this signal? This looks very easy, that a naught is nothing but average of this signal. And what is average? Positive area equal to negative area, so the average value is 0. Now we have to find out a1, a2 and so on. So better to find out an. The value of an will be in terms of n, and by putting n equal to 1, 2, 3 we can find out a1, a2, a3 respectively. So to find out an, this is a periodic signal. It means it will not start from 0, but it will come from minus infinity. A periodic signal will come from minus infinity and it will go to plus infinity, this way. This point is minus t by 2, this is plus t by 2. So let us find out value of an. For an, we'll write 2 by t integration for a duration of t. Here you can take any duration, it will depend upon the question. What is lower limit and upper limit you have to take. You can take it as per your convenience. For example, in this question, I feel that if I will take minus t by 2 to plus t by 2, this will be easier for me. If you will subtract lower limit from upper limit, you will get a duration of t. Ft cos n omega naught t dt. Now, what is the value of Ft? From 0 to t by 2, the value of Ft is constant at a, and from minus t by 2 to 0, value of Ft is constant at minus a. So we are required to take this integration, because in this whole duration Ft takes two values, so we'll have to break this integration into two parts. 2 by t, the first part will be minus t by 2 to 0, and what is the value of Ft in this duration? This is minus a cos n omega naught t dt plus 0 to t by 2, value is constant at a, cos n omega naught t dt, and 2 by t is multiplied with both terms. Now solving for this term, this will be minus 2a by t integration minus t by 2 to 0 cos n omega naught t dt. So its integration will be minus 2a by t into 1 by n omega naught, and this will be sine n omega naught t, lower limit minus t by 2 to 0. What will be the value of omega naught into t? Omega naught into t will be 2 pi So here you will have minus 2a by n into 2 pi. Upper limit is 0, so sine 0 will be 0 minus sine n into omega naught into t by 2 minus t by 2. So here we will have minus a by 2 is cancelled, n pi 0, and omega naught into t is 2 pi. 2 pi by 2 will be pi. So here you will get 0 minus sine n pi minus of n pi will be minus a by n pi 0 plus sine n pi, where n is an integer. So if n is an integer, the value of sine pi is 0. Sine pi, sine 2 pi, sine 3 pi, sine n pi is always 0. So you will get it as 0. So integration of this term is 0. In the similar fashion, if you will integrate it, you will get the same integration. Okay, you will get the same integration as cos n omega naught t, except in the lower limit you will have 0 and in the upper limit you will have t by 2. If you will put lower limit, you will get 0. For upper limit you will get omega naught into t by 2, and omega naught into capital T by 2 will give you pi. So you will have sine n pi, and sine n pi is 0. So this way, I'm not integrating it because it is same as the second term except the limit, and I know the answer. This will be 0, so you can check it. So the overall what you are getting, an is 0 irrespective of the value of n. It means a1 equal to a2, a infinity, all these terms are 0, and a1 is coefficient of cos terms. So we can say that in the sinusoidal representation of this square wave, there will be no cos terms because the coefficients of, or the amplitude of, all the cos terms are 0. Now we will solve for the coefficient or amplitude of sine terms. There is one easier method, the graphical method, to decide whether a coefficient is 0 or not. If the coefficient is 0, with the help of graphical method you will quickly find out whether it is 0 or not, because in many question in GATE you just need to find out whether a coefficient is 0 or not. So when you will solve those questions with the help of graphical method, it will take less time. But if the coefficient is not 0, you cannot find it by graphical. The absolute value you cannot find with the help of graph. So you also have to practice this formula with this method. If we will solve for bn is equal to 2 by t, and we will break this integration into two parts, minus 2 by t by 2 to 0, and the value of function is minus a, constant at minus a, ft is minus a, and here we have sine n omega naught t dt. After this I will solve, and or we will decide with the help of graphical method whether it is 0 or not, both for coefficient of cos terms and coefficient of sine terms. Plus 0 to t by 2. In this derivation, the value of function is constant at a. Let us solve for first term. this will be minus 2a by t, and integration of this term will be, integration of sine is minus cos, so minus 1 by n omega naught, and here we have cos n omega naught t limit minus t by 2 to 0. And let us second term also, let us take second term. Here we will have 2a by t into integration of sine is minus 1 by n omega naught minus cos n omega naught t limit from 0 to capital T by 2. I have already written minus here. For integration of sine, we will have minus cos, and I have already taken, okay, let's say it is minus cos, this minus will not be here. In this term I have taken the minus out, so this will be 2a into n, and omega naught into t will be 2 pi. Here we will have cos 0, which is 1, minus cos minus theta is cos theta, so I will not take minus n omega naught t by 2 plus 2a by n into 2 pi. Here we will have minus cos 0, and minus minus will be plus cos n omega naught t by 2. No, this will be positive and this will be negative. If you have minus sign inside, you will take cos lower limit minus cos upper limit. If you have positive sign, you will first take upper limit. If you have negative sign, you will first take lower limit. So this will be a divided by n pi. Cos 0 is 1 minus omega naught into t by 2. This will be pi. So you have cos n pi plus, here also a by n pi, 1 minus cos n pi. So basically you have 2a divided by n pi into 1 minus cos n pi. And what is the value of cos n pi if n is integer? If you draw graph of cos theta, this is, the graph will be like this. Okay, for 0 degree cos is 1, this is 90 degree, and this is 180 degree. This is 180, this is 0, this is 180, this is 360, this is 2 into 180, this is 3 into 180, this is 4 into 180. So what you are observing here, you have 1 into 180. If you have odd multiple of 180, you will get minus 1. Here what you have, at this point you have even multiple of 180. So if you have even multiple of 180, you will get positive 1, and for odd multiple of 180, you will get minus 1. So it has two values, plus 1 or minus 1, depending upon you have even multiple of 180 or odd multiple of 180. So let's say if this is value of bn, so what will be the value of bn when n is odd? If n is odd, you will have minus 1, and minus minus will be plus. You will have 2, and 2 into 2, 4. You will get 4a by n pi. You will get 4a by n pi if n is odd. And what about when n is positive? When n is positive, sorry, when n is even, when n is even, you will get plus 1, 1 minus 1 is 0. So Bn will be 0 for when n is even. And in case of an, there is no odd even, this is always 0. Okay, so for sinusoidal representation of this signal ft, I'm first writing the formula a naught plus a1 cos omega naught t plus b1 sin omega naught t plus a2 cos 2 omega naught t plus b2 sin 2 omega naught t, and so on. So a naught is 0 and all the a's are 0. Okay, we don't have an is 0. And in case of bn, if b is odd, like here we have b1, so for odd b this formula will be applicable, and for even b coefficient will be 0. So this is 0, and b1 will be, you put n equal to 1 here, you will get 4a by, this a is not for a1 or a0, a is amplitude here, 4a by pi sin omega naught t plus, this is 0 and b2 is also 0, so the next term will be b3, and for b3 we will put n equal to 3, 4a by 3 pi, this is third harmonic. Similarly 4a by 5 pi sin 5 omega naught t, and so on. So this sinusoidal representation is, this is sinusoidal representation of this square wave. In the sinusoidal representation of this signal, there is no even terms, there is no even harmonic. You have fundamental component, third harmonic, fifth harmonic, you have only odd harmonics, and even in odd harmonics you don't have any cos terms, you only have sine terms. So in further lecture I said that we will discuss graphical method for determining if a coefficient is 0. Okay, I said that I will cover in this lecture, but I'm sparing it for next lecture. And in further lecture we will also see that when a graph will have only even harmonics or only odd harmonics, or when a signal will have only sine terms or cos terms, by just looking at the original signal ft. So we will study, and this is one form of Fourier series representation. There is another form. In that form ft can be represented as ak into e to power jk omega naught t from k is equal to minus infinity to plus infinity, and k is integer, not any value. This is another form. Okay, you can convert this form into e to power form very easily, because sine is cos theta is nothing but e to power j theta plus e to power minus j theta by 2, and sine theta is e to power j theta minus e to power minus j theta divided by 2j. Okay, this is exponential form of Fourier series, and this is sinusoidal form of Fourier series. If we will do some manipulation in sinusoidal terms, what we have here, if we write sinusoidal terms in form of In compact form, what we will get, this is an cos n omega naught t plus bn sin n omega naught t. N is varying from 0 to infinity and n is integer. Okay. To this form we can also represent as, in one sinusoidal form only, this can be represented as Cn sin omega t n omega naught t plus phi n summation n equal to 0 to infinity. With some manipulation, this form can be represented as, in one sinusoidal form only with a phase difference. Okay, so exponential form and sinusoid this form and graphical method, these three things we will study in next lecture, and we will do more examples, because signal system is a subject of practice. With concept you should have a lot of practice.